Okay, so welcome to this webinar on the Computer Science Department. My name is Sriram Shankarnarayanan, and I'm being joined by Professor Christopher Heckman. So we are both faculty in the Computer Science Department. My research interests are in programming language theory, formal verification of computer and cyber physical systems. Professor Heckman is a roboticist. He builds self-driving cars. And that's my picture. You can see me right here. And that's Professor Heckman's picture. You can see him right here in front of you on the screen.
Hello.
So why computer science program? Well, there are many reasons to join us, and we are glad that you are interested. So first of all, we are a top-tier CS program according to the US News rankings. For instance, our engineering college is ranked about 34th among the best engineering schools in the US. And we are ranked about 40th among the best CS graduate programs. Interestingly, we are number one in the entire Rocky Mountain region, which extends from Colorado all the way up to Wyoming and other places. So we consider ourselves a really strong graduate program in computer science. And of course, we have faculty who have won lots of awards, including faculty who have won ACM Fellows, MacArthur Fellowship, which is one of the most prestigious awards that a professor could hope to win. We have 8 NSF Career Awardees. We have 2 Presidential Teaching Scholars. So overall, it's a very strong faculty. We have a very strong research program in areas like artificial intelligence, machine learning, robotics. We are particularly well known for human-centered computing, where 2 of our faculty are actually in the CHI Hall of Fame. We are also well known in robotics, programming languages, systems, CS theory, you name it. The other good reason to choose our program is because of the, I called it growth on the slide. I should call it an explosion of the interest in Boulder as a hub for the tech industry. Google's building a huge campus. They are already here. They have been here for many years. Oracle, Qualcomm, Twitter. So we have lots of employment opportunities and lots of tech savvy people.
As well as an explosion of startups I wanted to mention.
That's right.
So just from my lab alone, we've had 2 different startups grow out of it over the past 3 years. And both of them have been quite successful, and they've stayed in the Boulder area, which has been nice for them. And they've even gone so far as to get external funding from venture capitalists and, yeah, like I said, doing quite well.
So what to expect from our computer science program? Well, we pride ourselves on technically deep courses. We believe deeply in not just teaching about the technology of today, but in equipping our students so that they can stay ahead of the technology and they can actually be the drivers of the next big thing in technology. So you can expect technically deep courses in a bunch of areas. I have listed a few on the slide, like computer networks, computer security, machine learning, data science and analytics, optimization. We even have a new data science sub-plan to our master's program and a professional master's in data science. So these are really exciting classes. Our students really enjoy them. They get to do exciting projects as part of these courses. And we have a diverse group of students, especially at the graduate level, lots of international students, lots of students from Colorado as well as neighboring states, lots of students from around the US. So we pride ourselves on being fairly diverse as a graduate program. And we offer distance education. So the same classroom we are broadcasting this webinar from is one of the classrooms where our distance education students sit. Many of our graduate classes in computer science are taught in such classrooms, allowing people to join just like you're able to join in on this webinar. And finally, we have many degrees that support distance education. For instance, we have a Master of Engineering in Computer Science, a Master of Science with an emphasis on data science and engineering, which requires you to take specific set of courses in broadly defined areas that we call data science and data engineering. Master in Computer Science and an ME in Engineering Management, which many students find useful, and a MS with a focus on computational linguistics. So Finally, the advantages of distance education is master's degree increases your professional capabilities, so you're able to move up to a bigger role, maybe start being the next system designer in your company. And it allows you to stay ahead of the technology curve. So in some sense, if the current technology that you're working on happens to go obsolete, the fact that you have a strong technical background arms you to adapt yourself quickly to whatever is next on the horizon and stay ahead of the curve of the competition. Being a distance student means you do not have to drive into Boulder. The traffic can be very bad. And you still get the advantage of our experienced faculty. You can call into classes or you can watch the videos remotely. Yes, as I mentioned, you could network or call into class and participate in class live as the class is happening. And finally, you can access our classes or assignments at any time as a distance student. Well, that's all we have to say. So now we are open for any questions on the webinar. Yeah, so sure. So any course that we teach is available as a library course that you can take as a student remotely. And typically the way I have had a couple of students take my courses as library courses in the past. Typically the way it works is they contact the professor at the start of the semester and arrange for a schedule. So it's very helpful to have a viewing schedule or a lecture schedule, even though there are going to be no lectures. And typically you solve the assignments. The professor is able to grade the assignments, give them back to you. You can also get help by office hours, which are typically through phone or email. I've done both. Students typically prefer email. And overall, then there is usually a project component to most of these courses because we teach at the graduate level. And at the graduate level, you could choose a project from among a list of topics we provide, or choose a topic of your own that could help you or that you are specifically interested in. And you can go from there. And that's usually how a library course works. Pretty much like a self-driven course. The only downside I typically see in such classes, it's happened once that the student kind of couldn't catch up with the course in a regular basis, but typically you talk to the professor and then you arrange to catch up for these things. So that works as well. Yep, like this picture shows, you can really get up there on a mountain bike and actually work on your assignments.
This does look like it's coming from Flagstaff on the other side, perhaps.
That's right. You can see the back ranges there.
Yeah, that's what it looks like.
Yes, that could be you working on your assignment, I guess.
Although you'd have to haul your laptop up on your mountain bike.
That's true. And you might need networking, which may not be available.
So my understanding is that we have some, well, first let me answer that in two different parts. Our PhD programs are a fully funded program, in which case if you get admitted to the PhD program, then you are working directly with a faculty member. And either you're funded on one of his or her funded programs, or you have a TA position, or perhaps you've applied for a fellowship and been so lucky to be awarded one. So that's answer A. Answer B, for master's students, there is funding in different kinds of avenues. They usually come in either partial RA, if you have a relationship with the advisor that you establish and that you've designated as sort of somebody that you can work directly on one of his or her projects that's funded. We do have some master's students that are funded at least in part through that, with some tuition reimbursements as well. Some TAs do routinely open up in our department that allow a master's student to be able to teach potentially, although that is a very significant time commitment, so sort of depends on the individual master's student whether or not that would be a good arrangement. And then for my lab, for instance, we do have research assistantships available fairly regularly. Right now I am employing 3 different master's students to work on different aspects of building robots for me. And so that's that goes from everything from algorithm development and writing code to doing electronics work or mechanical design. And so that would be my sort of top-level answer to the question.
Right, and to add to that, yes, we have master's students who are TAs in our classes. We do have master's students who work as RAs. One caveat there is master's students who are on a professional master's program, and that's the big difference between a professional master's and what we call a traditional master's, for the lack of a better term, is professional master's students are not typically going to be RAs or TAs. Our expectation is they are here for a short time to finish their classes and move on with their job. So that's typically how that program's been envisioned. So, but people who are in our traditional master's program definitely do have the opportunity to do RAs and TAs. Typically, it requires establishing, like Chris said, a relationship with the professor first. In my case, it means taking 1 or 2 of my classes, doing well, and showing an interest in our research. And that's typically how we start working with master students as our RAs. Oh, in fact, we do.
In fact, we do.
This Saturday. So this Saturday, we have a graduate recruiting event where our graduate social committee and the faculty will be there. I will be there. Chris will be there. We will be there to talk about our research, about the master's and the PhD program. It's this Saturday. Send me an email in case you would like to know more. If you would like to talk to individual faculty or students, we could arrange that as well.
There will also be graduate students at the graduate recruitment day this Saturday. And typically when folks email me and they're interested in coming here for any sort of capacity, even undergrad, then if they can make the trek all the way out to Boulder, then I definitely would have them connect with some of my graduate students if they're interested, and if that would help them, make decisions. I can appreciate why that would be. It definitely helps to understand more about the culture and the environment and how often you would interact with faculty members. So, thank you for asking. So, are there any other questions?
Yes, you can. Typically, we require you to take prerequisites. And if you would like information on these prerequisites, we would be happy to talk to you about them. There's typically 4 or 5 courses we look for in these prereqs. If you can take them from any university as a non-degree student and get good grades on them, we are quite happy. And then if you can also show a little bit of experience with the subject, that's good enough for us.
Yeah, broadly, I would say that having no CS degree is not going to hinder anything beyond just when we look at your application, when we ask the question, will this person have the capacity to perform well in the classes that we're teaching here? And so you could have been an electrical engineer that took a lot of computer science classes, and there would be absolutely no concern, or a mechanical engineer or something like that, where you had more of an emphasis in that direction. But that's the primary reason why we would be looking at those courses, and curious as to, whether or not you would come here and sit in graduate algorithms and be way over your head. That's a concern that everyone would have. So, as Sriram said, taking some courses before applying would definitely help, just in not just for your application, but also bolstering your own strength when it comes to hitting some of these graduate classes.
Correct. Well, you have our email addresses.
Yeah, thank you for listening, and please email if there's any further questions that come up later.
And please do try to come here on Saturday if you can. We promise it will be worth your while.
Good. Thank you.
Thank you.